This video training covers the KLA-Tencor P10 located in the Burke Nanotechnology Center. All users must complete the Burke safety training prior to entering any of the labs in the Burke facility. This SOP is located next to the tool and is available at any time during use of the P10. Once started, the monitor will turn on and allow you to move the trackball to wake up the computer. If you should come to the tool and it's on this screen, you will need to double click the profile icon to get it to the top level menu so that you can double click the scan button to start the software. There are three primary default recipes that most people will want to use: the step height medium, the step height low, or the step height high, which is the step HTH. These three recipes were set up around the standards that were recommended by KLA-Tencor, and so these are available depending on the step height that you need to measure. You always want to go higher than what you anticipate your step height to be. In our case, we are going to use the step height medium, so by double clicking that, we will open up the editor menu, and on this menu we will find the scan length, which is predefined. It's a drop down menu. It's set for 2000 microns. The scan speed, which is how fast the stylus will go across that 2000 microns. The sampling rate, which is how many times per second the capacitive sensor is looked at, and then the average of how many scans will be taken. In this case will be 2. We always want to scan from left to right, so the stylus is always going from the left to right across the sample. On the bottom section of the screen, the scan time is predetermined based on the selections you made above as far as the scan length and the scan time. A stylus force is going to default to 2. That is a number you can type in. We prefer that you use 2 or 1 for small or for softer materials. Most times it's going to be 2. The contact speed is at 3, and we prefer that you just leave it there to avoid damaging the stylus. Vertical ranging is predefined by the recipe you select. Once the recipe is selected, we will want to select the XY button located at the top, and by doing this, it'll take us to the Teach Scan Length screen, which gives us a live image of where our sample is going to be measured. We must first load our sample, and so we're going to select the manual load button. The little blue dot shown here shows where the stylus location is relative to the platen. So when you click the manual load button, the platen will move forward, allowing us access without getting near the stylus. Once that stylus or the platen has stopped moving, we will open the front plexiglass door and load our sample onto the exact center of that platen. And you can see here the center has a number of vacuum holes in it. We want to make sure we put our sample over those vacuum ports, positioning it so it's in the very center, because that's where the stylus is going to land. And then we turn the vacuum switch on. We can then close the plexiglass door. Once the door is closed, we can go back up to the menu and press the manual load button again, which will cause the platen to move back into the tool. We can now press the focus button, which will bring our sample into focus so we can see where we're going to be measuring the area of interest, and it brings the stylus in close proximity to the surface. As you can see here, it moves into position. The blue line here in the very center is the path that the stylus is going to travel to measure. We can move the sample around by using the 4 arrow buttons here at the top shown right now. I'm moving it up and down, left and right. Or we can take the cursor, put it on a point, double click, and it will move that point to the center of the field of view as shown here. Once you've done that, you can go back up to the arrows and move that sample around until you get to the area that you have interest in measuring. Now that the area of interest has been positioned so it's going to be under the stylus, so the stylus can scan across it, we can press the start button. This will initiate the stylus coming down and then starting the scan across the area of interest that we've defined. Notice in the lower right corner there's a profile image of what is being detected by the stylus as it goes across the surface. Once the first scan is completed, the stylus will back up, start over, and scan a second time, and that second scan will now be a blue line and it should superimpose over the red one. This will give us an average between these two scans should there be any anomalies picked up on either one of the scans, so we get a good number for a measurement after the scan. Before we can get an accurate measurement, we must first level the profile that was just scanned. Notice the top cursors on this image. That's for leveling, and the lower cursors are for the actual measurement. To level the scan, we must first determine which plane we're going to use. The two planes must be at the same level. We're going to press the level button. That will activate the two level cursors, and then we're going to move these two cursors so that they are over the same plane on the scan we just performed. The yellow arrow there shows the top plane, and we have placed the cursors on the lower plane. We can also adjust the width of these cursors, which gives us an average of all the points in between each of the highlighted lines shown here. Once positioned, we hit the level button again. Now we can position the measure cursors. One must be on the lower plane as shown here, and then the cursor on the right is on the upper plane, the arrow here showing the red bar on the lower plane. Again, you can separate, widen this cursor to get an average of more data points along that top plane shown here with the yellow bar. Once we have those two cursors positioned, we can look next to step height shown here with the red arrow, and we see that this is measuring 7.9. If you wish to go back and measure a different point on your sample, you can click the XY button again and move the sample around using the up, down, or left, right arrow keys, or you can redefine the scan path as defined with this blue line. If you left click and hold the mouse button, you can use the trackball to move across and redefine what that scan path is going to be. You can make it shorter or longer depending on when you release the left mouse button. In this case, I'm going to shorten that scan path that we previously had. Notice in the lower left corner, it gives us the distance between each hash mark, which is 100 microns. I can now start a scan with the new path that's been defined. It is still going to make 2 passes across the sample in the area of interest. But notice in the lower right corner, the profile is much shorter now and only shows the step down. We have the first one in red just as before, and now the second scan is a blue line that overlays the first. And now we will need to re-level because the leveling is still in the same position it was for the last scan. You can see here that the scan now is quite skewed. So I'm going to press the level button. I'm going to choose the lower level as defined or shown by the yellow arrow, making sure both of the level cursors are on the lower plane. I will then press the level button again. This activates the measure cursors. I'm going to position the left cursor over the top plane. I can now move the right cursor over and spread it out some. And I'm seeing here I'm still getting 7.97 microns for my step. Again, it's taking the average of all those data points in between those 2 highlighted lines on those measurement cursors. I could have also leveled on that top plane. The only real difference in doing this is the width of those cursors have to be smaller, and it's going to redefine that top plane at the 0 angstrom level. Once we're finished taking measurements, we'll need to hit the XY button again so that it raises the measurement head, and it will move the platen forward, giving us access so that we can unload our sample from the tool. I have to first open the plexiglass door and turn off the vacuum switch before removing the part. And we should also make sure that we keep our hands away from the measurement head and the stylus. Once the part's off, we will press the manual load button again, which will cause the platen to move back into the tool, at which time we can make sure that the door is closed. I left the door open in this case for the video for ease of seeing the platen movement. Once it's done, we want to go up in the upper left corner, click on the box and click close. When we're on the scan page, we want to do the same thing. Click the upper left box and click close. And then finally click File, Exit. When you do this, a dialog box is going to come up asking if you want to save any of this information. The answer to this is no. Do not try to use the USB ports on the computer. They do not work. And we now get another dialog box giving us a choice. Do we want to save changes with a new recipe, or discard changes? We want to make sure we either save the changes as a new recipe or discard the changes. Those are the only 2 options I want you to be able to use. Do not overwrite the default recipe. In this case, we're going to go ahead and discard the changes. Click OK. That takes us back to the top level menu. At this time, you can go into iLab and finish the session, which will disable the monitor as shown here. Pressing the keyboard spacebar or trackball button will stop the P10 motions at any time. Please do not load any soft materials on the P10 as it will contaminate the stylus tip.